Greetings, salutations, and welcome back to another video. Now, before I get into it, about the time that this video comes out, I will be travelling back to my student accommodation, so we'll see how that all affects my future uploads. As well as that, if you want to have a look at any of the tree frog photos from the tree frog that we did a time-lapse of last week, those will be at the end of the video, and yeah, feel free to check them out. But without any further ado, let's get into it. So today I'm going to be showing you how to make a nice and cheap filament runout sensor. It works on a buzzer, and it cost me only £1.81 bought in materials. The idea is very simple. You have a switch at the top here, which when pushed towards the arrow will activate the system. That's so that when there's no filament in it, you can turn it off so it isn't ringing constantly. And for headphone users, I must warn you that you may want to turn your volume down now, because I can hear this from downstairs when it's upstairs, through the floor and across the house. So let's pull this out and we'll see what it's like. As you can see, switching that off. Okay, I'm done. You can raise your volume again now. But switching that off just deactivates it. It runs on 4 small batteries in there, and I've included a little chamber in here so you can put a little bit of foam in to act as a dust filter. Links to all the things that I'm using will be in the description below, and the first thing you want to do is go to the Thingiverse link and print off these parts. I've designed these to be printed at 0.1mm layer height, and they do not have any inbuilt tolerance correction, so you're going to want to put on your horizontal compensation on your slicer. I use 0.15 in Simplify 3D, and that works perfectly for me. I do use less for the battery cover so that the little grooves that allow it to slide in, as you can see here, and hold, so that they have a nice decent fit. First off, you're going to want to get a 5-volt buzzer like this. The polarization should be marked. This is just off eBay and is rated at 85 decibels minimum. Next, you're going to want to get a wheeled micro switch, and you want to make sure that it's in this orientation, so you have common, normally open, and normally closed in that order. That's actually quite important for the assembly. It's one of the constraints that I had to work with when designing. To that, you want to add this simple switch, a couple of 10mm long 2.5 screws. That's another little constraint that I had to work with. I was hoping to use M2 screws, but couldn't find any of the correct length, so they're M2.5. It's not a big deal, but just something to be aware of. You'll of course want a little bit of wiring. It doesn't have to be thick, you're not taking much current. A bit of PTFE liner, which you should have hanging around from your 3D printer, and of course batteries. These are designed to use LR41 batteries. Those are also known as AG3 batteries and are 1.5 volts each, so in series will come to 6 volts, which is above our threshold voltage. But basically this is the layout you want. You probably want to have your positive coming out through the bottom here. That's not entirely crucial, it's a very simple basic circuit and it shouldn't make too much difference, but it's good practice. And the batteries will line up here. You can put your piece of foam in there, and of course the PTFE Bowden tube will run through here in order to just remove some of the friction. So first off, with this, we only need 2 of the poles and we only need 1 of them. So I'm just going to cut these off here. And then as you can see, they're slightly long, so I'm just going to trim them down here. And that should now fit nice and neatly in there. I'm not going to push it in fully because obviously I need to solder it up, but there you go. Next, the micro switch needs to go in there. We don't need the middle leg, and we need to trim these down slightly to fit, and that should slot in there like so. Just check that the activation point of your switch feels okay. It's a bit precarious. If it is a bit off, then you might have to bend the lever slightly to compensate for that. Next, we're going to get the PTFE tube to the right size. This end is better quality, so I'll be using that. I'm going to have it coming out slightly, so I'm going to cut it here, and I'll just use a knife for that. Now, as that is a blind entry for the filament and I want it to run in smoothly, I'm just going to take the knife like so and just very gently pare around the entrance and carve off a little chamfer that should help guide the filament in. Next, we're going to want to cut the hole that the wheel is going to fit into. So it's going to be here. And we don't want to cut right to the end. We want to leave about the wall thickness at the end. So I'm going to do this very carefully. And it's okay to give it a bit of extra distance. And there we go. Now, as you can see, a little bit of the wall is left. You can either trim that down by knife, or what I find works quite nicely is to use needle files. So I have here a round needle file, and I'm just going to file it to improve our finish. And the reason for this is that we want enough material at the bottom for the filament to run along smoothly, but we don't want so much material that it's going to impinge on the wheel. Now again, because we have what is technically an entrance point here, I'm just going to try and pare that down slightly to help align the filament, just in case something goes wrong. Now, while that's in position, hold it down firmly so it doesn't move, and just check that your button is activating properly. If not, trim it down a bit more. It looks like I need to take this further this way, just to ensure that your button will trigger. As you can hear there, we're now getting a nice activation. And it doesn't feel like that's going to impinge, so that is as needs to be. Now that that's done, the next step is to cut our wires to length. So I'm going to cut my wires first, and then I'm going to cut my piece of metal to act as a contact. Now this is going to take hardly any wire at all, but it's best to have too much than too little. So I've measured it at roughly there, allow a bit more for bending. We'll cut it here. If there's any more, we can just trim it down as needs be. And that'll be plenty, that's actually too much. So next we want to cut a contact, and here I have a piece of scrap metal that I've just been slowly biting away at. And let's cut off a section so we can get a nice clean edge. So choosing this corner as probably my most square. So just want to make that twice as wide, so from that scratch, which you can probably not see, there we go, I'm just going to double that, add a bit more and cut it off. You'll see why I've added a bit more. So the reason we added a bit more was so that we can bend this over at a right angle, like so, and that will slot. I'm going to round off the corners a bit so that it's nice and smooth, and then I'm going to cut a little crimp on here because I know that this metal doesn't like to solder. But that's okay, if your metal does, then just solder. If it doesn't, then making a small crimp is probably your best choice. Not perfect, but it's just a battery contact, so it will do. Next, I just want to cut here. And then finally, we're going to just cut down the middle. Oops, if I can get these. And that's going to create. So, on to the next stage, soldering. So first off, we're going to strip the wire ends, and there are multiple ways of doing this, as I'm sure you're aware. I'm just going to do what I usually do. And so, to begin with, I'm just going to solder these two wires onto here. Once we've got a joint soldered, we do a quick pull test just to make sure that it's attached properly. What we want to be careful of here is that there's still room enough to get around that tab, which it looks like there will be. In fact, there is plenty. So I'm just going to push this a bit more. So now that that's pushed in, like so, we can see that we want to cut it roughly here. And making sure not to solder the positive, we're going to solder. And there we go. Now, as you can see, that bit of solder there is probably going to impact on the edge there, but that's okay. I can easily deal with that just by removing a tiny bit from here with my hot iron. Just going to melt that down a bit. And then now that that's
Not
those
too
two
bad.
sides
There's a
done,
slight
I'm
gap
going
there
to show a
showing
quick
that,
test fit
something is in the way
to make sure that that's not
this-
too big a deal, and for this demonstration I won't bother fixing that up fully. So going on to the ohmmeter, I'm going to set it so that next thing to do buzzes, like so, whenever we make contact. I'm going to quickly check continuity between the joints. That's obviously in the off position, so we're not expecting any current. And from the sounds of it, we have a broken microswitch. If I put that to common and that to this side, we get no difference. So here is the old one that was soldered in, and as we can see, if I apply across there, there's no signal. What we should be seeing is with this new one, which I've already cut down and pre-soldered, is that we get a connection across there. So I'm just going to solder it in and then check it again. Excellent. 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 All done. Now we just need to put this back in place. And the fit works well. So now it is time to insert the PTFE and the piece of foam. So I try to insert them both at the same time, like so. In fact, this looks a bit wide, so I'm going to just trim it down slightly. So finally we were going to screw it together and then mount it. Now mounting it foam in there, so you're just going to push it 2 and 3 holes here and here, and the distance between them will be on Thingiverse. Like so. Okay, so it seems this one is a bit loose, and that's probably because of these, but I can just reprint another one and it should fit on nicely. So we're going to take bend down this leg. I suggest just inserting the battery so that we get the proper fit. I'm going to be putting them this way around. Of course, if you put yours in and they turn out not to work, then obviously just swap them around, because it just depends on the polarity. As you can hear, there's already some screaming. I'm just going to turn it off for now, quickly. then stick this one in here, completing the circuit. So, if you close that up, there's a slightly bad connection in there. But that can be fixed, that's not a problem. If you do find yourself having a bad connection in there, one of the easiest things to do is to just slip a bit of aluminium foil between the batteries and the contacts. That usually sorts them out. I mean, it's not a proper sprung contact, so it's not going to be perfect. It's as close as we can get, really. So I'm just going to insert a piece of filament here and test that that function is working. Warning again, you may want to cover your ears or turn your volume completely down. Now engaged. Excellent. So there we have it. We have two fully functional, really small, really compact, and really cheap little filament runout sensors that you can just screw in like that. These batteries are 35 milliamp hours. The piezo buzzer is informative, of course, links are down in the description to everything you need, and I hope you find these useful. So thank you very much for watching, and I hope you'll join me again soon. Goodbye.